Hello everyone, I am M. Katyayani from 3rd BSc Mathematics Aided. In this video, we are going to explore some of the important concepts in the complex analysis, power series, and how to find the radius of convergence for a particular series. First of all, what is power series? An infinite series of the form summation n equal to 0 to infinity an z power n equal to a0 plus a1 z plus a2 z square plus etc. plus an z power n plus etc. Since the series is infinite, where the coefficients a0, a1, a2 etc. an and the variable z are called the complex numbers. Grouping this, we get the power series. Consider one example. Consider the power series. The partial sum is given by summation n equal to 0 to infinity z power n equal to 1 plus z square plus etc. plus z power n minus 1 plus etc. The partial sum of the series is given by Sn equal to 1 plus z square plus etc. plus z power n minus 1. Since this series is in the geometric series, therefore the sum of this geometric series we get Sn equal to z power n minus 1 divided by z minus 1. When modulus of z is less than 1, the sequence z power n is converges to 0 as n is tending to 0, and hence this sequence Sn is converges to 1 divided by 1 minus z. The power series converges when modulus of z is less than 1 and modulus of z is greater than or equal to 1, then the series is divergence. In generally, if modulus of z is less than 1, the series is convergence. Otherwise, modulus of z is greater than or equal to 1, then the series is diverges. Now we see what is radius of convergence. The radius of convergence R is any number such that the power series will converge for modulus of x minus a is less than R and diverges for modulus of x minus a is greater than R. The power series may not converge for modulus of x minus a equal to R. The interval of x values including the endpoints for which the power series convergence is called the interval of convergence of the series. If the radius of convergence of the series is R, then a minus R is less than x is less than a plus R. This x is lies between a minus R and a plus R. In this condition, the power series convergence. If x is less than a minus r and x is greater than a plus r, in this condition the power series is divergence. Therefore, the radius of convergence of a power series will be a half of the length of the interval of convergence. If r is the radius of convergence, then we can define the interval of convergence as a minus r comma a plus r. In generally, every power series is convergence inside the circle and diverges outside the same circle. Now we going to see about some elementary function in the power series: exponential function, rational function, and hyperbolic function. First, what is exponential function? Consider the power series summation n equal to 0 to infinity z power n divided by n factorial. By putting n equal to 0, we get 1 plus n equal to 1 z divided by 1 factorial and so on. The nth term of the series, that is a coefficient of z power n is an. Therefore, in this series an equal to 1 divided by n factorial. And an plus 1 equal to 1 divided by n plus 1 factorial. Letting limit n tends to infinity, and modulus of an divided by an plus 1 equal to limit n tends to infinity 1 divided by n factorial divided by 1 divided by n plus 1 factorial. Solving this, limit n tends to infinity n plus 1 factorial divided by n factorial. This n plus 1 factorial can be written as n factorial into n plus 1. Therefore, n factorial and n factorial is getting cancelled, which is equal to limit n tends to infinity n plus 1. Substitute n equal to infinity, we get infinity, r equal to infinity. Therefore, the radius of convergence for this series is infinity. Hence, the power series converges at every point in the entire complex plane. So, it is analytic. this series 1 plus z divided by 1 factorial plus z square divided by 2 factorial and so on is similar to the e power z. We know that the formula for e power z is 1 plus z by 1 factorial plus z square divided by 2 factorial plus etc. Therefore, the function e power z is defined for every value of z and is also analytic in every domain. When we differentiate e power z, d by dz of e power z is always e power z. Then what is rational function? A polynomial of degree n in an expansion of the form p of z equal to a0 plus a1 z plus a2 z square plus etc plus an z power n, where a0, a1, a2 etc are complex numbers. The above series converges for all z. The quotient of two polynomials of the form. When we divide p of z divided by q of z, we get the quotient of this polynomial. P of z divided by q of z equal to a0 plus a1 z plus a2 z square plus etc plus an z power n divided by b0 plus b1 z plus b2 z square plus etc plus bm z power n is called a rational function. Such a function is analytic at all points of plane except when the denominator is 0. Next, hyperbolic function. The hyperbolic sine and hyperbolic cosine of complex variable. We know that the hyperbolic function for sine and cos, which is sine hz and cos hz. We know the formula for sine and cos hz in hyperbolic function is cos hz equal to e power z plus e power minus z divided by 2. Sine hz equal to e power z minus e power minus z divided by 2. We know e power z and e power minus z are analytic in the entire complex plane as seen in the previous slide. It follows so that the sine hz and cos hz are also analytic in an entire complex plane. Now we are going to explore some of the problems in the radius of convergence. First, summation 1 by n power n into z power n. What is the nth term of this series is the coefficient of z power n, that is an equal to 1 divided by n power n. Taking power raised to 1 by n, therefore modulus of an the whole power 1 by n equal to 1 by n power n the whole power 1 by n, so that this n and n getting cancelled, which is equal to 1 by n. We know for every value of n, 1 by n is converges to 0 as n tends to infinity. Therefore, we get 1 by r equal to 0 or r equal to infinity. The radius of convergence for this series is infinity. Therefore, the series convergence for every value of z. Then the next example is summation n equal to 0 to infinity z power n divided by n factorial. The nth term of this series is an equal to 1 divided by n factorial and the an plus 1 equal to 1 divided by n plus 1 factorial. Now modulus of an plus 1 divided by an equal to 1 divided by n plus 1 factorial divided by 1 by n factorial. Solving this, we get 1 by n plus 1 n factorial divided by n plus 1 factorial. This n plus 1 factorial can be written as n factorial into n plus 1. N factorial is getting cancelled. We get 1 by n plus 1. Also, we know that 1 divided by n plus 1 is always tending to 0 as n tends to infinity. Therefore, 1 by r equal to 0 or r equal to infinity. We get the radius of convergence for this series is infinity. That is the series converges for all values of z. Now move on to the next example. Summation n equal to 1 to infinity z power n divided by 3 power n. n in this series, the coefficient of z power n, that is an equal to 1 divided by 3 power n, and the coefficient of z power n plus 1, that is an plus 1 equal to 1 divided by 3n plus 1. Letting limit n tends to infinity in modulus of an plus 1 divided by an equal to 1 divided by 3n plus 1 divided by 1 divided by 3 power n. Solving this, we get 1 divided by 3. letting limit n tends to infinity, we get 1 by 3. Therefore, the radius of convergence is r equal to 1 divided by 1 by 3, which is equal to 3. The final answer the radius of convergence is 3 for this series. I hope you are all understand the concept of our series and how to find radius of convergence for some examples.